Imagine a world bathed in the dim glow of a distant sun, a world where the sky is dominated by a colossal, swirling giant of a planet. This isn't a scene from a science fiction film, it's Europa, a moon of Jupiter, a place that has become a focal point in our search for life beyond Earth. Its surface is a mosaic of ice, crisscrossed with long, dark fractures that hint at a secret hidden beneath. This secret, a vast ocean of liquid water, has transformed Europa from a seemingly desolate, frozen wasteland into one of the most exciting places in our solar system. The story of how this ocean came to be suspected is a testament to human curiosity and our ability to decipher clues from the cosmos. It began with a spacecraft, a robotic emissary named Galileo, sent to explore the Jupiter system in the late 20th century. As Galileo flew past Europa, its cameras captured images that sparked a revolution in our understanding of this icy moon. These images revealed a surface unlike any other. It was relatively smooth, lacking the numerous craters that pockmark most moons and planets. This suggested that Europa's surface was young, constantly being renewed. But how? The answer, scientists realized, lay in the gravitational dance between Europa, Jupiter, and the other large moons. Imagine holding a rubber ball in your hand and squeezing it repeatedly. You'll notice that the ball heats up. This is similar to what happens to Europa. As it orbits Jupiter, the giant planet's gravity, along with the gravitational pull of the other moons, stretches and squeezes Europa, a process called tidal flexing. This constant flexing generates heat within the moon, enough heat to melt ice deep below the surface, creating a vast, global ocean. The Galileo spacecraft provided further evidence for this hidden ocean. Its instruments measured Europa's magnetic field, and the readings were peculiar. They suggested that something electrically conductive was moving beneath the surface. The most plausible explanation was a salty, liquid water ocean, sloshing around as Europa orbited Jupiter. Think of the sheer scale of this hidden sea. It's estimated to contain more water than all of Earth's oceans combined, a vast, dark realm hidden beneath miles of ice. The existence of this ocean alone is a profound discovery, but what truly ignites the imagination is the possibility that it could harbor life. To understand why this isn't just a wild fantasy, let's journey back to our own planet, to some of the most extreme environments imaginable. Deep in the Earth's oceans, far from the reach of sunlight, are volcanic fissures known as hydrothermal vents. These are essentially underwater geysers, spewing out hot, mineral-rich water from the Earth's interior. The areas around these vents are incredibly hostile. The pressure is immense, the temperatures fluctuate wildly, and it's perpetually dark. Yet when scientists first explored these depths using submersibles, they were astonished to find thriving ecosystems. Bizarre creatures like giant tube worms, eyeless shrimp, and ghostly fish had adapted to this extreme environment, forming a complex web of life. But how could life exist in a place without sunlight, the primary energy source for most life on Earth? The answer is chemosynthesis. Microbes living near the vents have evolved the ability to extract energy from the chemicals dissolved in the vent fluids. They form the base of the food chain, supporting the entire ecosystem. These discoveries revolutionized our understanding of life, proving that it can flourish even in the absence of sunlight, using chemical energy instead. Could similar ecosystems exist in Europa's ocean? The same tidal forces that heat the moon could also drive hydrothermal activity on its seafloor, creating vents analogous to those on Earth. These vents could provide a source of energy and nutrients, allowing life to take root in this alien sea. Let's consider another example from Earth, one that further strengthens the case for life on Europa. Beneath the vast, frozen expanses of Antarctica lie hundreds of lakes, sealed off from the surface for millions of years. These subglacial lakes are cold, dark, and under immense pressure, yet they are not lifeless. Scientists drilling through miles of ice have found microbial life thriving in these isolated ecosystems. These hardy microorganisms have adapted to survive in this extreme environment, demonstrating the remarkable tenacity of life. Europa's ocean, covered by a thick layer of ice, shares some similarities with these subglacial lakes. It's a realm shielded from the harsh radiation of space, a potential haven for life. While Jupiter's intense radiation bombards Europa's surface, making it uninhabitable, this same radiation might actually play a role in creating the building blocks of life. Imagine the radiation striking the icy surface, breaking apart water molecules and creating other chemical compounds. Over time, these compounds could seep down through cracks in the ice, eventually reaching the ocean. These radiation-produced chemicals could serve as a source of food for any potential life forms, supplementing the energy provided by hydrothermal vents. The idea of life existing in a hidden alien ocean is captivating, but how would we even begin to search for it? This is where the next chapter of our story unfolds, with a new generation of robotic explorers poised to continue the quest. A mission named Europa Clipper, scheduled to launch in the near future, will be our next scout in this grand adventure. Clipper won't land on Europa. Instead, it will orbit Jupiter and make numerous close flybys of the moon. It's equipped with a suite of sophisticated instruments designed to study Europa in unprecedented detail. Think of Clipper as a cosmic detective, gathering clues about the ocean's properties, its depth, its saltiness, the thickness of the ice shell that encases it. It will use radar to peer through the ice, mapping its structure and searching for pockets of liquid water closer to the surface. It will also analyze the moon's faint atmosphere and any plumes of water vapor that might be erupting from the surface. These plumes, if they exist, could offer a tantalizing shortcut for sampling the ocean's contents without having to drill through the ice. Imagine Clipper flying through a plume, its instruments scooping up tiny particles of water and analyzing their chemical makeup, searching for hints of life, perhaps even organic molecules, the telltale signs of biological processes. But the ultimate goal, the holy grail of Europa exploration, would be to land on the surface and directly access the ocean. This is a monumental challenge, far more difficult than anything we've attempted in space exploration before. The radiation environment is harsh, the temperatures are frigid, and the ice is thick and unpredictable. Yet despite these challenges, scientists and engineers are already dreaming up concepts for future lander missions. These missions could involve landing near a crack or a region of thinner ice, perhaps using a probe to melt its way down to the ocean. Once there, a robotic submarine, an autonomous underwater vehicle, could be deployed to explore this alien sea, equipped with cameras and sensors to search for signs of life. However, this exploration must be undertaken with extreme care. The possibility of life on Europa raises important ethical considerations. We have a responsibility to protect this potentially unique ecosystem from contamination by Earth-based microbes. This concept is called planetary protection, and it's a crucial aspect of any mission to Europa. Imagine a scenario where a spacecraft carrying Earth microbes crashes on Europa. These microbes, adapted to Earth's environment, could potentially outcompete any native Europan life, disrupting or even destroying the very ecosystem we're trying to study. To prevent this, spacecraft bound for Europa must undergo rigorous sterilization procedures, ensuring that they are as clean as possible, like a surgeon meticulously sterilizing their instruments before an operation. The search for life on Europa is not just a scientific endeavor, it's a profound exploration of our place in the universe. If we were to find life there, even microbial life, it would revolutionize our understanding of biology and the prevalence of life beyond Earth. It would suggest that life isn't a unique phenomenon restricted to our planet but a common occurrence, perhaps even a fundamental property of the universe like gravity or electromagnetism. This journey to Europa is a testament to human curiosity, our innate drive to explore the unknown, and to answer the fundamental question, are we alone? The answer may lie hidden beneath the ice of a distant moon, waiting to be discovered. It's a story that is still being written, a story that could change our understanding of life itself. As we continue to explore, to develop new technologies, and to push the boundaries of our knowledge, we move closer to unlocking the secrets of Europa, and perhaps discovering that we are part of a much larger, more vibrant cosmic tapestry than we ever imagined. The cracked, icy surface of Europa, once a symbol of a desolate, lifeless world, could become a symbol of hope, a beacon in the search for life beyond Earth, reminding us that the universe is full of wonders waiting to be unveiled. The story is far from over. In many ways, it's just beginning, a narrative that speaks to the very core of our being, our yearning to understand our place in the vast, mysterious cosmos.